massive floods, record high temperatures, rising sea levels. These are all words that have become more prominent in the past decade than ever before. The word climate change, global warming, they're used generally, usually every day, but many people don't appreciate or understand the magnitude that this implies. In a study called the Climate Change Impacts the United States by the United States Global Change Research Project in 2009, the amount of CO2 in our atmosphere has increased from 290 parts per billion to 395 parts per billion in the past 100 years. For 1,900 years prior, this remained steady around 290 parts per billion. Never even touched the 300 range for 1,900 years. The average classmate in this class, according to the survey results, releases about 11.7 tons of carbon dioxide each year. Now, alright, so in this speech, after I share my knowledge with you today, you will leave the classroom hopefully understanding the factors and effects associated with climate change. Now, the first point we're going to cover is greenhouse gases, and that's affect our environment, along with a very new and rising unpopular material. Secondly, we'll cover humanity's impact, and thirdly, we will cover the future projections for our planet within the next 100 years. So, greenhouse gases, and cryogenic, but we'll say that probably that is a new and rising term. Greenhouse gases, obviously, we've all heard of them, we all know what they do, but we haven't obviously existed for hundreds of years to see the time span of what they've done. So, in the documentary Chasing Ice, that was directed by Jeff Borowski in 2012, they decided to do just that and see what kind of research they can get within just years from the effects of greenhouse gases themselves and what this does to our glaciers. So, this is a disrupt image, so we're going to just use this again. Imagine that the original image only showed this. This was 100 years. This is it. This is a western, this is in western Greenland, this is glacier in western Greenland, and this is 8 miles of ice that decayed over 100 years from 1902 to 2001. This is 9 miles, which happened in 9 years. So what initially took 100 years is now done in less than a decade. And this is still accelerating. This isn't just at a constant. This is still accelerating and accelerating. Now, for cryogonite, this is cryogonite. Cryogonite is a mixture of soot, which you could, for visual representation, soot is the picture of the black smoke released from diesel engines. That mixes with dust and gets into our atmosphere, and it'll fall sometimes on our glaciers, and it'll create these. Since it's black, it absorbs heat from the sun, rather than the sunlight or being reflected off of the ice. It now has some black apparatus that absorbs it. And as you can see, it's becoming ever deeper. You can see the depth going in. And what these will do is there will be millions of these deposits all throughout miles and miles of glaciers. And they'll begin to expand and go deeper. And what that does is, as it goes deeper, it begins to have actual water, not just ice. And this water starts to focus weak points of the glacier. And as it does that, it will act as this slow-moving knife that cuts through the glacier as it goes deeper and releases it into the ocean. So now that we understand some things that affect our environment from greenhouse gases and the new material cryogonite, let's look at what humans have done. As we know, humans have released many of the harmful gases, normally just CO2, water vapor. And although these are natural, and we've aided in the process since the Industrial Revolution, we've also released new, extremely rare, man-made, and dangerous chemicals. Fluorofluorocarbons, which you may have heard from halon. Fluorofluorocarbons are found, they were prominent in the 1900s. They stopped around 1987. I'll touch on that later. They are found in refrigerants, coolants, solvents. They're used. This is the active fluorofluorocarbon in hairsprays back then was used to propel the spray. You couldn't have hairspray without fluorofluorocarbons. And what this does is it gets trapped in our atmosphere. and it's trapped in our atmosphere anywhere from 20 to 100 years. It can even exceed 100 years. It usually averages about 80 years. And for every one molecule of chlorofluorocarbon, it can decay 100,000 molecules of the ozone. Now, halons are the exact same thing as chlorofluorocarbons, but pretty much on steroids. Halons do 10 times the amount of damage and last 10 times as long. We won't expect to see halons decay in our atmosphere until the next generation, hopefully. If I could just cite this study. In the study Chlorofluorocarbons, titled by James Elkins in 1999, which was found on the Earth System Research Laboratory page, it wasn't until 1987 that 27 nations agreed to stop this. Though some nations still do permit, very few of them do now. They're still getting into our atmosphere now, most of them have stopped. The Earth, according to the Encyclopedia of Earth, the natural Earth, which is titled Carbon Footprint, which is published on April 5th by Maggie Wilsner, 20 tons of CO2 are emitted per person in North America every year. So if you had to put that in sort of a unit, imagine if every average American would submit 48 million volumes of carbon. That's sort of the reference size that we're dealing with. And this is just North Americans, the average North American. So now that we understand what humans have done, let's look at the future predictions, our final point. And we'll see that, well, we'll just hold on to that. The same study that I used to sort the parts per billion change, the United States Global Change Research Project of 2009, they predict that the average global temperature will increase from 2 to 11.5 degrees Fahrenheit within the next 100 years. Now, this graph, as we can see, this is done by the 2007 Global Climate Change Assessment by the Intergovernmental Panel on Global Climate Change. All of these right here represent ideal situations, obviously going from most ideal to least ideal. This is factoring in how much CO2 we release, what kind of emissions we do release, how many we release. Obviously the best ideal is still rising, and that is not, it's ideal, but it is not so much realistic. We're expected to be in this shaded area around here, regardless of what we do, which is going to hit a 2-degree increase by 2050, regardless of what we do. Now, the implications that has just beyond 2 degrees is substantial on its own. This can, according to the EPA, this can release, this can change migration patterns for birds. If a bird is told by its temperature to migrate to a new location, but it's wrong, it can get there early, and there won't be food for it to thrive on. This increases the ability for pathogens and parasites to thrive, because we all know that they need a warm environment so that they can live. This also increases, this is a very classic example of food web disruption, which is represented here by the NOAA 2011. Unfortunately, due to the government shutdown, I can't give you more info on the NOAA, but what we see here, these green phytoplankton represent ice algae. What these ice algae do is they thrive on nutrient pockets in the ice.
Go to your conclusion.
Okay. In conclusion, hopefully you understand at least some of the factors and effects and appreciate the magnitude that global warming has on our planet and our habitats. I think I've given you enough statistics and graphs for today, so I think instead I'm going to leave you with a quote from Al Gore, which says, "The warnings of climate change have been extremely clear for a long time. You're facing a global climate crisis. It is deepening. You're entering a period of consequences." Although climate change is a very miraculous and beautiful process to study, we still have to appreciate how serious and potentially dangerous it is.